Hey, Excel fans, we're going to do a walkthrough of the Axel the Elf's Christmas Catastrophe. This was the case that was the last chance qualifier to the Microsoft Excel World Championship in 2024. So we got a 30-minute timer, and let's start. First off, convert this data into tables. I usually like to do a little bit of cleanup on the columns just for easy reference. Okay, that out of the way. So now I'm gonna have a start battle macro, which imports my lambdas. Now I've got my lambdas. This is just an easy X lookup. Looking up name, returning the state. Okay. Naughty or nice. So if there are at least two of these attributes, then they're on the nice list. So we're going to go over here and do if count if greater than 1, and they're nice unless they're naughty. Now just copy this X lookup and change this to nice. Alright, most requested toy from each state. So it's going to be, I'm going to use like a group by. Not the name, the toy. Gotta do a filter, don't we? Yes, we do. T-states. What's that? The blocks. There we go. Most requested toy. But you have to know if they're naughty or nice. So very similar to this one. I'm actually going to start with that formula. And the only thing we have to do is add a filter for naughty or nice. So here's our filter area of the formula. And just chain our conditions. Let's see. Nice equals to the bear. How many trips will sanitate to each of the following states? Okay. So, each time he has a capacity of 10. Alright, so first thing I'm going to do is get like a list of the toys that are in the spaces that they're going to take. So, we'll do this as a let. So the names is going to be alphabetically sorted. Filter name based on what? The state. Okay. Spill. Let's move this out over here. Okay, so we got the names. Working good. Let's get the toys. I don't know if we need the toys or not, but I'm going to say sort by. And this is going to be filter T state equals. What are we sorting by? We're sorting by the name. I did something wrong here. Sort by there. Okay, we got our toys. Actually, we could have just done an X lookup. Do the X lookup now for the space, how much space it takes. We're going to look up each toy in the toys table and return how much space it takes. Okay, so we have a list of spaces. And this is sorted. So now we need to see how often Santa makes a trip. So the idea is that he starts with a capacity of 10, he takes 8, he has 2 left. He has to make a solo trip for this toy because there's not room for the next one. Okay, so the way I'm going to model this is called capacity. And we'll do a scan space. And so we'll say if existing capacity minus that value is less than 0, then the capacity is going to be 10 minus v. Otherwise, it's 8 minus v. And let's see. Oops, spelled it wrong. Okay, so looks interesting. Now I have to model when does Santa actually make those trips. So let's create a new variable called trips. And it's going to be mapping space and capacity lambdas. And then we're going to say if the capacity equals 10 minus space. That means we're doing our trip. Okay, I probably didn't explain that super well, but it looks modeled correctly. So those are our trips, and then the goal of this is just to sum how many trips does he have to make. Right, okay, so something like that. Good. Alright, what is the first letter of the surname of the first person being delivered with the nth delivery? So it actually turns out that we need a lot of this same data here. The only thing that's different is we're looking for specific delivery amounts. So I'm going to add on from this model, we need a total or cumulative trips. Oops, I'm getting used to using the Python editor. Okay, so we're going to say total trips is going to be span trips. So all right, and so now we want to see which person is the first for the nth delivery. So that's just positional lookup. So we're going to say index names match total trips. Index names that's Not exactly what I was expecting. Oh, I know why. These are in the wrong order. There we go. And so with that, we just want first letter of the second name, which is text after. That. Okay. Here we have a new table. Times snacks. Oh, you know what? I want this to be an actual table. Snacks. Snack. Seconds. Okay. How many seconds does Santa take to make all of his deliveries? So he goes 5 seconds for every trip. And then for each person, if they're nice, then he takes time to eat the food and drink. It's underlined. It says they eat the food and drink at the same time, so it's going to take the maximum of the 2 items. Okay, so where do we start? We'll start with how many trips. We already solved that part of the problem. Bringing down this. So this is number of trips. Now we just need to say filter H stack T food. Actually, should be able to do this. T food drink on T state equals that. And we need to chain our conditions to also find T nice equals nice. Okay, so that would be a list of snack, food, and drinks. And we're gonna look these up to find out how long each one takes. So snacks, seconds. And then we want the maximum of each row. It's going to take 2.5 seconds for the first one. So we're going to do just a by row. Our max are, we can just do max, right? Yes, sir, we can sum that up. And so our answer is round this times 5 seconds plus this, rounding to 0 digits. Okay, and the bonuses. How many children have first names beginning with X, M, A, or S? So we're just going to filter. We're going to count a filter on not is an A, match team left team to an array of letters. Nice. All right, how many children are fair, mindful, welcoming, and compassionate? Okay, so I think we can do something like this. So we're going to say equals T, mindful, fair, fair to compassionate. all these values. And so if we do these like by row, I wonder, yeah, and doesn't work there. Lambda R and R. That doesn't seem to work. Oh, it does. Okay. So we just want to count, sum those up. Yes. All right. Which surname appears? So this is my first like lambda I'm going to use. Most of. We want text after team. Easy. Alright, based on the available data, which data is repealed in nationwide ban on water toys? The toy has only been requested in a single state. We could do a formula for this, but I think the quickest way is just going to be a quick pivot table. Sometimes quick and dirty is better. State, toy. And so it's clearly the dartboard here is only one value, and that's from New York. Alright, assume that A equals 1, B equals 2, C equals 3, and then eta equals what is the highest scoring children's first name. Okay, so we're just going to map the names. So Max has map T, actually before, text before T name, and N for name. Okay, so for each name, then we have to go through the letters. We're going to sum up. We're going to sum map sequence length of the name. And lambda, that's L for letter. So now we need to do code of the letter, which is mid and L1. Subtract 64 for all uppercase, but I think we need to convert these to uppercase first. Okay, so minus 64. That's the number for each one. Add those up for each name. And max. Boom, done. Alright, not bad. 18 minutes. And that's a wrap.